Now, one of the things that I find when I do these study groups is there's a lot of questions that we talk about. This is something that, fortunately, I have a chance to really sit down with and go through a lot of the things you send me. And as we do these study groups, I'll also remind you that I have the entire Network Plus course. Every single video that you might want to see, they are all online. You can watch them absolutely free on ProfessorMesser.com. But if you need to take them offline, there is an offline version of this as well. You can find out more about that at ProfessorMesser.com/download-Network Plus. And of course, you can always do things like follow us on Twitter and follow us on YouTube. There's links there. If you ever need to find me anywhere, you can go to ProfessorMesser.com/YouTube, ProfessorMesser.com/Twitter/Google Plus/ type something in and you'll find me if I'm there. So I will occasionally even just put things there of links to other pages that I hardly go to, but sometimes people will find me that way. I find that's pretty interesting. So that's another thing that you could do to help support what we're doing here. Now, as I mentioned, I do this every month. So last month, we had a ton of topics, and a lot of the questions that I got this month duplicated some of the things that we talked about last month. And I'm not going to duplicate this again, but you can easily go back to last month and look at some of the things that we talked about. One of them was, what's the difference between segments, packets, and frames? Another one is someone asked if I could go over routing protocols, especially dynamic routing protocols and how they work. I went through dynamic routing. We talked about that with RIP and EIGRP and OSPF and others. Someone asked, what is API-PA used for and when is it used? And I went into a great deal of detail on that one. We were in the chat room earlier this month even we were arguing about what IP addresses are really given to stations with API-PA. And a lot of websites out there are completely wrong. So you may want to check the specifications, the RFC itself, to find that out. And we talked a little bit about that last month. I have multiple NICs in my system. How does Windows or Linux determine which interface to send data? So we talked about routing tables. Does a VPN using OpenVPN have a pass-through for HTTPS, or does it re-encrypt? Is it encrypting twice when it does those things? We talked about that. And I have books for the N10004. Should I get the N10005? And what port numbers will show up on the test? And finally, how can I renew my Network Plus certification without taking the test? And I have a follow-up to that this month. So these topics we covered last month. So we will not be covering these topics this month. But there's some good stuff in there. So you may want to go back. You can find the replays at the top of the Professor Messer website is a pull-down link for Network Plus, and the study group replays are in there. I also put the study group replays at the bottom of the Network Plus video index page. If you go to freenetworkplus.com, it will redirect you to that. And if you go to YouTube, I have a playlist for all of those, so you can find it there. Try to put them everywhere. No matter where you are, how you get this information, I try to find a way that you are able to get your hands on those things. So our question this month is about the Network Plus certification. And for those of you that have followed us before, I'd like to ask you questions during the study group. So if you have a QR code reader on your mobile device, this would be a good time to make use of that QR code reader. The question that I have for you to start with, this will be something we use to kind of get things going, is how long have you been studying for your Network Plus certification? This gives me a chance to find out what you have been doing. I'm one of these people that have to study over a long periods of time. There are other things going on in my world. So I tend to get an hour a night or 2 hours a night when I'm studying towards a certification. It seems like I'm always studying towards some kind of thing. So I'm constantly trying to get in additional time. So it doesn't take me 6 weeks. It takes me 3 months, 6 months, sometimes over a year to get some of the certifications. I have a list of certifications that I would like to get, and it takes me a while sometime to finally get through that list and be able to look at those things. It can be a bit of a challenge sometimes to find the time. So I want to know from you, how long have you been doing this? And I'm going to see instantly on our screen here, if you go to vot.rs and go to 72684, you can vote on that or use your QR code reader. The link out here, as you can see, will give me an interactive response of what you did and how you are studying and how you were able to make use of these things. There is quite a bit in studying for the Network Plus certification. It's a big certification. There's a lot to learn. So you may find yourself having to spend a lot of time to study. That's why I always look at the folks that are 9 months to a year, over a year, 6 to 9 months. Those are my people. And then those are just getting started. Always nice to see those as well. There's a lot of organizations. Here we are at the beginning of the year. You're starting classes, and these classes are about 3 or 4 months long. And then you get to that as well. So there's a lot of great things that I can learn by the things that you're going through in your life. Now, I'm going to have other questions for you throughout the study group. You will be able to answer questions. The questions I have will be more pop quiz questions. So I'm going to help try to give you an idea of what I'd like you to learn today, and you'll be able to tell me what you know about those pieces. So that's a very good example. You can see here we've got a lot of us, the vast majority studying today, are less than 3 months and 3 to 6 months. And fortunately, a lot of the topics I have today really focus on the beginnings of what you need to know for the Network Plus certification. We're going to talk a lot about OSI. We're going to talk a lot about switches and routers. We're going to be down there with the equipment this month. I don't really pick a theme. It just kind of worked out that way. Before we get to that, if you are someone who is working with the Network Plus certification, you'll notice that it currently has a version name of the N10005. The N10005 is the number that is associated with Network Plus. There's another number if you're an organization that's a CompTIA member. It may have a JK0 associated with it, but it's the same test. The Network Plus exam, everything all over the world uses the same version of the N10005. We have there's a lot in N10005 that's been added since the N10004. There's usually updates about every 3 years, and the Network Plus was updated about 2 years ago. I would imagine this time next year we'll be looking at a refresh of that somewhere in here, maybe the end of this year. But they usually have quite an overlap. So even if they said today there was a new version, you'd have 6 to 9 months still to study. So you're good there. Don't worry that you're going to have the rug pulled out underneath you. There's always plenty of time to study for these certification exams. There was a lot of differences, a lot of things added to this that brought the Network Plus up to the latest type of technologies, things like virtual networking, things like the OSI model, things like more security, a lot more security on this Network Plus certification. So it will be interesting to see how that works. And I would imagine, so this came out in December 2011, 2012, 2013. So December of this year, maybe we might see a refresh. It's not always exactly 3 years, but I think that's what they try to do. They have plenty of time. And even then, let's say they bring it out in December, you've still got another 6 to 9 months. That's usually what they do, is give you an overlap. So you've got plenty of time. And who knows what they'll call it? Chat room, and what will they call it? The 006? Who knows? Probably, because the last one was 4. The one before that was 3. So it would make sense that it was the 006. But we don't have to worry about that today. If you're looking at the Network Plus certification, everybody's taking exactly the same version anywhere around the world. Now, let's say you've been studying for your Network Plus, you have been going through the videos, you have a book, and you're now getting ready to really work on that last bit of studying. And a lot of things that people have asked me about is how they can take all of the content from my videos and have them all on a single study guide. So I created one. This is the Network Plus study guide from ProfessorMesser.com. If you go to the Professor Messer website, I've made this study guide first inexpensive. So for $10, you get all of these study guide materials that I've created on my website. And I've tried to put everything in there for the Network Plus. If you were to look and see all of the things that we do, in fact, I'll show you a picture of this. This is the study guide. So I have pages and pages and pages of all of the things that you see in my videos. And now I've just got them shrunk down into this one PDF file. And this goes all the way down into the security part, 11 pages of content on the study guide, just lots and lots of material. So if you're interested in getting something like that, a lot of people were asking for something like that to have on their PDF, and it's a free and open and available PDF. So when you get it, you can put it on all of your mobile devices. As long as you're the only one using it, you can put it on your iPad and your Android device, on your computer, on your laptop, on your computer at home. I want you to be able to have access to this information wherever you might go. And I tried to price it so that everyone would be able to afford that. And what's great about this is you're buying this electronic version from my website. It's only $10 and it goes directly to keeping the website up and running. Our hosting costs are now well over $1,000 a month just to keep things going. And so it's great. We've gotten great response to these. So I really appreciate the support for that. It's remarkable what we're able to accomplish by contributing in and keeping things going on the website. And it's taken a lot of the pressure off worrying about those pieces. You can find out more about that at professormesser.com/netsg for Network Plus Study Guide, NetSG. So this is a very a good start into the things that we are going to talk about now, because we went through a lot of content, or I looked through a lot of content, a lot of questions that came through. So get your QR codes reader. I will remind you not to answer these questions in the live chat room. Let's keep this a mystery for everybody to be able to see. The question that I have for you deals specifically with switches. And then the question that came in this month is, which of these would be commonly associated with an unmanaged switch? You can click the QR code there, or you can go to vot.rs and go to 695929, 695929. I didn't plan that. These are all random whenever I make these numbers that come up. And the number is 695929 at vot.rs. It's one of those things where I start looking at trying to understand infrastructure. And this is, I notice, a challenge of people who, you're not in the industry, you're not working with certifications, you're not working in a data center. And so trying to figure out all of these different devices is all a brand new thing. So one of the things that I wanted to be able to do this month is step through some of these infrastructure devices and help explain how it's used in the enterprise, in larger organizations, in even mid-sized organizations. And one of the questions and one of the things you need to know on the Network Plus certification is, what is the difference between those types of pieces of switches, of types of switches? There are managed switches, there are unmanaged switches. What's the difference? And in this case, what would be a commonly associated with an unmanaged switch? The questions, or the possible answers that I have for you are 802.1q, spanning tree protocol, traffic prioritization, SNMP, port mirroring, none of the above, or all of the above. So which of these would be commonly associated with an unmanaged switch? Is it all of them? Is it none of them? Is it one of them? You have to tell me. Now, as we're going through that, I'm waiting for you to vote. I'll also remind you that on the professormesser.com/live, if you are watching this live, I have call-in lines for you. You're welcome to call in with a question at any time and queue up. Just remember to listen in on the line, because there is a delay and you won't hear me pick up the phone and try to talk to you. You can also, you'll notice there's an 800 number if you're using Skype. You can Skype in for free. There is a lot when we deal with unmanaged switches and managed switches that we have to think about. And there's a lot of options I have here for you. I try to do these questions so that there are multiple steps that you have to go through in the question. I don't always do it this way, but I try to when I can, because to answer this question, you have to know what 802.1q is, so that you can then understand, does that apply towards an unmanaged switch? You have to know what SNMP is. Some of these things I did not abbreviate because there's just too many abbreviations there. But we have 40 responses. Let's see what people said the answer was. And 18 of you, which is the most of all of these answers, said none of the above. But interestingly enough, we sort of had people respond across the board for what they felt an unmanaged switch would have associated with it. So let's think about what this is. In fact, one of the questions in here, in the chat room, somebody said a practice question referred to a layer 1 switch. Is there such a thing? We're going to talk about that in just a moment. There was a question on Reddit I was reading last night about replacing a repeater with a switch, and would that work? So let's talk about first the idea of an unmanaged switch. This question that came in was one from Elijah, who said, is there a way to track bandwidth flowing through an unmanaged switch? And the only way you would know the answer to that would be if you knew what an unmanaged switch was. I'm going to come back to the answer, by the way, of the pop quiz question in just a bit. I'm leaving you hanging, and we're going to come back to that, I promise. So the idea of tracking bandwidth. So this would be more of an advanced management capability on these devices. But first we need to understand what is really an unmanaged switch. So I went into my closet yesterday. I pulled out an old gigabit switch that I had. This is a gigabit switch that had some copper ports on it, had some fiber uplinks on it. This is a good example of an unmanaged switch. And the reason it's unmanaged is because there's very little management functionality that you have associated with this switch. It's almost like a dumb device. You plug it in and that's it. There's nothing to configure. There's no switches, there's no buttons, there's no management interface, there's no console port, there's no login to the device. You don't assign it an IP address. It's unmanaged. There really isn't much to work with there. There's no way to configure VLANs on the device, so you can't change individual ports to segment them out and put them in their own virtual LAN on the switch itself. That's a challenge when you're working in larger environments. You may want to do that. You can't do that traditionally with an unmanaged switch. You also have very little integration with other devices. So there are no management protocols. The way that many people will gather utilization statistics over time, especially bandwidth utilization, is they will use a protocol called SNMP. And you can see on that map that I had here, this chart I had here, one of the answers was SNMP, the Simple Network Management Protocol. That protocol is designed for you to be able to query information from an infrastructure device like a switch, like a router, like a firewall, like a server, and ask it a question about how it's doing. So how much hard drive space is still left on that server? Please tell me. Or say, Mr. Firewall, what's your CPU utilization? Or in the case of this, on your switch, how much bandwidth is going through an interface? If it's an unmanaged switch, it doesn't talk. It doesn't have the ability to communicate via SNMP. So in that particular case, I have no way to understand how I'm able to get statistics from that device. It doesn't have a counter inside of it that's gathering those statistics. It doesn't have the CPU, the knowledge inside of it, the code inside of it to be able to gather those statistics over time. And it doesn't have a way to communicate back to you via SNMP with those. The advantage, of course, is that because it doesn't have all of these advanced capabilities, pretty cheap, pretty inexpensive. I shouldn't say cheap. They're fine boxes. They're fine devices. They will run and run and run for you. They are completely functional as far as a switch is concerned, but they don't have additional capabilities that you might need when you're in an office environment. They might be great for your house, or they might be great for an environment where you don't need any of those additional features. But almost anytime you get into medium to larger organizations, you need some of this functionality. So there's no way that you're going to buy an unmanaged switch for something like that. When you get into managing these devices, when you're going to be in a building, the switches could be in the building that you're in. They're not in the same room. You can't see them when you're sitting at your desk. Certainly they might be on another floor. They might be in another building. They might be in another state. They might be in another country. So you need some way to gather information about that device. An unmanaged switch is not going to be the way to do that. For those environments, you need a managed switch. And since I was taking pictures yesterday, I went into the switch that I have that everything is running through right now. This is a picture of it. In fact, you can't even see it really, but in my office, I have this studio. I have racks to the left and right of me. And in the rack that's to the left is where the switch is. And so I got this switch and took a picture of it. There's a lot, you can see I've got a lot of devices in my network. Look at all the devices that are plugged in. This is all self-contained. There's a lot of things obviously on the desk, but there's all a self-contained piece here that all of these things are plugging in to a single subnet for the most part. Actually, the audio is on a different VLAN, but for a single subnet, everything is going into this one switch. It's an HP switch. It is a managed switch. There is an IP address associated with this switch. Since I'm thinking about it, I'm going to try to find my the switch configuration here so you can get a feel for what I mean. Except I have to remember where I have the IP address. I have a database of all the IP addresses that I keep in a file, and I just have to find that file. Oh, I found it. Let's see if it's actually there. And it is. Let's see if I remember the login. And I do. So a managed switch gives me additional capabilities. Maybe I can configure VLANs on the switch. Maybe I can set up traffic prioritization so that if the switch sees traffic coming from a certain device or a certain type of traffic, maybe I give it a higher priority than others. Maybe there's an important application that we use in this environment, and anybody who's using YouTube, we're going to put them down into a lower prioritization so that our mission critical application works even if everybody is trying to watch cat videos on YouTube. There's often redundancy capability in the way of spanning tree protocol. Certainly being able to prevent loops is important on enterprise environments. SNMP is a capability that we have there, and certainly port mirroring to capture packets. So you're able to see a lot more from a managed switch. You're able to get a lot more detail about that piece. Yeah, that was a spider connected kind of config. Now, if we look at the management front end of this HP device, let's see if I can show this to you. Here we go. So here is my switch. So we've got a lot of information already on the screen. We know it's managed because it has an IP address. Here's the current status of everything that's plugged into it. Some of these devices are set up in certain configurations for me. I don't have any uplinks. I don't have multiple switches in this environment. You can see all of the system description. This is SNMP information right here. So there's a good example of where you'd pull SNMP. This is a very common SNMP string to be able to see this. 1.3.6.1.4.1.11. That's called an OID, an OID. But here you notice I can get a lot of information about how the switch is set up. I can look exactly how port configurations are done, if this supports jumbo frames or not. Can I do port mirroring on this device? Can I assign flow control features to it? Can I enable or disable certain power saving features? I wouldn't be able to do this with a device that was not managed. So this is a good example of how you can take a managed device like this and be able to customize it to do whatever you would like to do in your environment. I think it becomes very useful when you start working with that. Yeah, I know there's a lot to see in that view, a lot of things in that configuration. But that's one of the things that is important to me in this environment. Even though I'm one person in a room, I have a lot of requirements for things like port mirroring. I need to be able to assign different VLANs on the switch. I need the switch to be quiet, so maybe I can customize the power settings or the green settings on this device. Really allows me to do quite a bit with this. And at the end of the day, this 24-port switch that I have here, relatively inexpensive. So wasn't much of a difference to purchase and have those managed capabilities in your switches. So a good idea. So let's go back. Now that we're thinking about that, let's go back and look at the answer to what we were looking at, which would commonly be associated with an unmanaged switch. Well, 802.1q, that's managed. Spanning tree is managed. Traffic prioritization managed. SNMP managed. Port mirroring managed. The 21 of you that said none of the above were absolutely correct. The 7 of you that said all of the above would be correct if this said which of these would commonly be associated with a managed switch. You 7 folks would be correct. But in this case, the 21 of you that said none of the above were absolutely correct. There is a lot going on with these. Oh, now we're having a fight in the chat room, by the way, because I showed you the graphical interface to the switch, and people were poo-pooing it, saying, "No, we do command lines. That's how you network." And this switch, I believe this switch supports command lines as well, but it's much easier when you're trying to get an overview of what's working now and what's not. It's nice having that graphical view. I like having devices that have both available to be able to do something with them, and this device does as well. There's quite a bit that you can do with this. So one of the questions also that came in about this technology on a managed switch, we were talking about SNMP and how you're able to communicate via SNMP. SNMP is a standard. It's a protocol, and it is a standard. It's a standard way of querying devices, regardless of what those devices are and regardless of what you're querying from. So you can have queries that are taking place via SNMP from a Linux device. It could be Mac OS X. It could be Windows. It could be a third-party operating system. It could be Android. It could be iOS. That could be talking to a device via SNMP and querying it for information and having that information come back. And the device we're querying could be, who knows what it could be running. It could be running anything, because it could be a firewall. It could be a router running its own router operating system. It could be a switch. It could be a server running Windows, or a server running Linux, or a server running OS X server, or a server running anything. The beauty of SNMP is that it's so standardized that you're simply, as long as you make the correct, simple request to that device, you're able to get the response from that device and do something with it. So very nice to be able to support that capability. All right, I have another question for you. Do not answer in the chat room, but we're going to stick with this idea of infrastructure devices. And the question that I have for you is, which OSI layer is associated with routing? And I should probably say most commonly associated with routing, because routing is something that has a particular OSI layer that people most often think about. And you can go either click the QR code reader or go to vot.rs and choose 648709. This is one of those things that when we're trying to work the OSI model and understand how the OSI model works, we need to understand what happens at different layers. And there is a OSI layer associated with routing. The options available to you are layer 1, layer 2, layer 3, layer 4, or layer 7. This will be an interesting one to look at. Then we can all fight over what routing really means after we're done here. But there is a sort of a standard perspective. You can also take this question, which OSI layers most commonly associated with routing? I would say is associated with routing, because this is the one that really is. Go to vot.rs and vote 648709. And I will remind you the phone lines are open, so I'll be glad to take your calls as well. Those numbers are at the bottom of professormesser.com/live. And again, I apologize, I'm not able to take any direct questions on the website right now. But if you have a question, just put it in the chat room. You have something specific, put it in there. We'll all see it and be able to look at it. I have about 36 responses. The OSI layer associated with routing, layer 1, layer 2, layer 3, layer 4, layer 7. I'm going to take some coffee. And that's why I like to have something here so I can keep talking and keep talking and keep talking. Okay, we got 46 responses. I think it's time to see what the answer is. Which OSI layer is most associated with routing? And wow, 40 of you said layer 3. Nobody said layer 1. Nobody said layer 7. Two of you said layer 2. 5 of you said layer 4. Obviously, in this case, the vast majority of you are absolutely correct. 41 of you said, yeah, layer 3 is the one that is most associated with routing. So let's figure this out then. What are these differences when we talk about routing, when we talk about switching? This is a common question that I will get coming through. The difference, this one's from Reagan that said, what is the difference between a switch and a router? And this is a common question that comes up because these devices are always, they're doing different things, but sometimes they're referred to as the same device. Sometimes a single physical device might have the capabilities inside of it to both switch and to route, which really only serves to confuse everyone. So in this particular case, we're going to break these things out. We're going to talk about switches that switch, routers that route, and we'll break them down and talk about comparisons between them in those pieces as well. The switches that came through, if we look at switches, and this is, of course, that unmanaged switch that I have now sitting next to me because I drug it out of my closet to take a picture for you. This is also something called bridging. Sometimes when people say, I need a bridge, I need to bridge between these two subnets or these two networks, they really are referring to switching. We used to call it bridging because we would have this physical box called a bridge, and it was able to take data from one device or one network and send it over to a different network. When the capability to do all of this in silicon very, very fast with many, many ports on these devices was introduced, we called them switches because it sounded great. Switch them. It's really fast. It's exactly the same thing. The key here is that it's doing it in hardware and something called an ASIC, an application-specific integrated circuit. It is something specifically designed in hardware to be able to take data and move it around from one network to another. And when we talk about these different networks, we're really talking about moving information at layer 2. The networks themselves, at the most fundamental layer of addressing, are able to send data back and forth at MAC address. These devices, it's important that these devices know all of the different MAC addresses on the network. In fact, you could have devices that had no IP address associated with them, these switches would still be able to transmit information back and forth as long as they were using things like a layer 2 address. This was very common back in the day before TCP/IP was widespread. We would use protocols like NetBIOS that would only communicate at layer 2. They didn't have a layer 3 address. So the only way you could send information between different networks was with a bridge or with a switch. This is very, very useful to have whenever you're trying to send information. The beauty of a switch, of course, is that switches have a lot of ports on them. This one has very few. This one has, 10 ports, 8 ports on it. But you can get some switches that are enormous boxes that you need many people to hold to put into the rack that are 100 pounds, and they have many slots on them, and they have hundreds and hundreds of ports on them. And in those large data centers, that's very common for you to find. In my environment, I have a lot of different kinds of switches. None of them are that large, but obviously the more ports you have, the more things that you can support. In data centers, obviously, you need a lot of interfaces and a lot of ways to communicate between all of those different devices. One of the nice things about these switches also is that they are able to communicate at very high bandwidths. And one of the beauties of the backplanes of these devices is that devices on ports 1 and 2 can be talking to each other and nobody else on the switch even knows it's going on. Devices on port 10 and 11 can also talk to each other at high rates of speed. And because they are all switched between each other, nobody else on the network is affected by those file transfers. So you can get very, very high bandwidths occurring across multiple devices all at the same time. What happens on a pair of devices doesn't affect another pair somewhere down the line. Another great advantage of this. The key to switches is that it always is able to communicate. It makes its forwarding decisions on layer 2, on, in the case of Ethernet, a MAC address. So when you're talking about how a switch determines how the traffic gets between point A and point B, switches don't care what IP address you have. They don't know anything about IP address. They don't look at the IP address. They don't care about the IP address. All switches do is take a MAC address that's coming in as the source. It looks at the destination MAC address. It looks at a big list of MAC addresses that it has in memory because it's been watching where all the traffic goes, and it sends the traffic out the appropriate port. That's all it does is look at things by MAC address. Really, really useful to have that capability there. Now, of course, there are times when we want to do communication between networks, between IP subnets. And in those particular cases, we need a device that has a routing functionality. Whenever we talk about routing, we're talking about communicating between devices at layer 3. We're talking about devices that make their decision about where traffic goes based on an IP address. So in the same way that switches didn't care what the IP address was, routers kind of don't care what the MAC address is either. Ultimately down at the lowest layers, it has to send information using MAC address, but it makes its routing decision, it makes its forwarding decision, we often say, by looking at the IP address, looking at a big list of what port goes towards that IP address, and it sends it out that connection. I mentioned last month, we did an overview on routing tables. And if you'd like an overview of how does it make that decision, how does it step through that big list and be able to send information the right way? If I'm sitting at my desk, how am I able to communicate to Yahoo? How does it find its way to Yahoo? My computer doesn't know how to get to Yahoo. Yes, but every router along the way does. And as long as it goes to a router and asks that router, could you tell me directions to this? So, oh, sure, you need to go out this interface. Off I go till I get to the next router where it asks again, I'm looking for Yahoo. How do I get to Yahoo? You go out this interface. And it's all based on the IP address of that device. So whenever we talk about the OSI layers, layer 2 is a router, layer 3 is a router, layer 2 is a switch. So always think switches are layer 2, routers are layer 3 as we step up the OSI model. One of the things you'll find with routers, and it's a little bit different than switches, is that routers often connect to many different kinds of physical interfaces. Whenever you look at a switch, almost always all of those switch interfaces are Ethernet or some speed of Ethernet. But when you start looking at routers, we're almost always going through and communicating to different types of connections. It might have WAN connections or serial links on the back of it. It might have for really older networks, might have other types of topologies on there other than Ethernet. Back in the day, these routers would have all kinds of interfaces, FDDI and token ring and Ethernet. There was ArcNet. There were so many different topologies. These days, we've shrunk it down into a much smaller subset of topologies. We have really Ethernet. In fact, our wide area network providers are often providing an Ethernet connection these days, but you could have SONET connections. You could have serial connections coming in for some of the slower links that you might have. These routers are so flexible. They have physical interfaces inside of them that allow you to route between Ethernet and a serial link, for instance. Very, very useful to have that, especially if you have a remote site that you can only communicate to via a T1 line or fractional T1 line. And that's a great way to route between their local Ethernet and the WAN connection that comes back to the corporate office. So that's your keys. When you're looking at the OSI model and looking at what is available and where you should be looking, your switches are always layer 2, your routers are always layer 3. Now, one of the things I didn't put in here, and it's worth bringing up, is that some manufacturers will have a switch and then they'll have additional software that you can add onto the switch that you can then change some of those switch ports to routed ports. So you can have part of the device that makes its forwarding decision at layer 2, and you can have other parts of the device that make their forwarding decision at layer 3. You can still think of them as completely separate devices. One part of this device is going to switch. Another part of this is going to be a router, as if you've got two devices and you crunch them together into one thing. You'll sometimes hear those called, in the marketing terms, a layer 2 router. You want to think of it that way, or even a layer 3 switch. Somebody in the chat room was talking about a layer 1 switch. The OSI model we've bastardized in our industry to try to work around times that we've scrunched these things together. So it's very common to see those terms used, like a layer 3 switch in that scenario where somebody's trying to do routing on a switch device. What they're really saying is that part of this device does routing, part of this device does switching. You can almost get away with not having to buy multiple devices. You can have them all on a single device so that you can do a little switching, maybe at a remote office, and then route out to the wide area network. Very useful. Some organizations, and so this is brought up in the chat room, some organizations are very focused on having routers route, having switches switch, having firewalls firewall. And there's I guess a good philosophy that you could look at associated with that. But when you have a remote site and you can get away with plugging in one power connection and managing one device, and that one device does routing and switching and maybe even firewalling in the same device, sometimes there's a good business case to be made from that. You just have to balance out performance, cost, and all of the other things associated with managing that device when you're working with those. Very, very common to see that. These days, firewalls can do routing and switching and bridging and forwarding and repeating. There's all kinds of capabilities to mix up those interfaces these days. So just keep that in mind as you're looking at some of these devices, that it's not always just a switch. It's not always just a router. It's not always just a firewall. Often they're blended together. And if you can remember what parts of those devices will work at those different model layers, OSI model layer 2, OSI model layer 3, OSI model layer 7, it will help you quite a bit, especially if you look at some of those higher end devices out there in the industry. Okay, I have another question for you. Before we do that, I'm going to go to the phones real quick. We have a couple of folks that are holding. Let's go to the area code 281. Are you there, caller? Somebody's there. Oh, coming over. Pick up the phone. Oh, so close. Gonna have to call back. I think we dropped them. Let's go to an area code I can't see. It comes across me in all ones. Are you there, caller? I think there's a microphone issue there. You can kind of hear the buzzing, can't you? That's the beauty of doing the live stream here. And there's no one here doing this with me, you'll notice. It's just me doing the stream here. So I don't have anybody to pick up the phones and to check in and to do that piece. If you are calling in via Skype, make sure you try the Skype test number. That will tell you if your microphone is working or not. And if you were in that 281 area code, you can call back and we'll get you on here as well. I have other questions for you. So don't answer in the chat room. I have another question for you. This one's specifically associated again with the OSI layers. I had a lot of questions about the OSI model this particular month. So I thought it would be good if we talked about the OSI model and what our options are associated with this piece. There is, again, no answering in the chat room, but the question I have for you, since we're talking about OSI model, is which OSI layer is associated with the spanning tree protocol? This is another one of those times where you have to know what the spanning tree protocol is. And then, of course, once you know that, you have to figure out what the spanning tree would fit into from an OSI model perspective. So go to vot.rs and go to 266240 to vote on that, or you can click the QR code and go to that piece and be able to do that. Yeah, I hate to be that guy. Turn down your radio. It's one of those challenges. You have to be able to hear it and do all of that at the same time. And the poor 111 person, this number came up as 1111111. They ended up dropping too. So somebody is listening in. Feel free to call back. We've got some lines open and do that piece. So the answers that are available to you for which OSI layers associated with the spanning tree protocol, the options are layer 1, layer 2, layer 3, layer 4, layer 7. So the same ones as before, the spanning tree protocol for those. Some folks are nice enough to put the link to that in the chat room. We've got 15 responses so far. Spanning tree, I think, is sometimes confusing. And one of the questions that came in this month specifically talked about spanning tree and why we use spanning tree and why it exists and what's associated with that. So I think there are a number of opportunities with spanning tree. In fact, I go to some organizations, and some organizations always have their spanning tree capabilities enabled. There's some organizations I go to that don't use it at all. So there's pluses and minuses on why you might use that and how you might use that. But we'll talk about that in just a moment. Well, we've got 39 responses. I'll let a couple of more folks come in and answer the question of which OSI layer is associated with spanning tree protocol. So let's see. We've got 43. Let's see what the answers are. So let's look at the results. 29 of you said layer 2, 10 of you said layer 4, and then we've got layer 3, layer 2, and layer 3, layer 1, and layer 7 as some of the outliers here. Well, obviously in this case, layer 2, with now 30 folks saying that the OSI layer 2 is associated with spanning tree protocol would be correct. It is not layer 3, it is not layer 4, it's not layer 7, it's definitely not layer 1. So let's talk about this. And the reason I bring this up was Eliza asked the question this month that said, why do we need spanning tree protocol to prevent loops? We don't have these problems with layer 3 routers. There's no loop protection with layer 3 that we have to turn on. So it seems inefficient not to load balance to have. It'd be nice to have multiple links to a single location. It would be useful to have that in place if we had it. So there's the challenge, is why do we have spanning tree? What is up with that? Let's talk about spanning tree for a moment. The STP, you'll see this called often. It'll be abbreviated as STP. If you look at a MAC layer communication, and let's say you connect a couple of switches back to each other, and you're watching the traffic go back and forth with something like a protocol analyzer, you'll notice that the two switches know what the other side is, and we send something like a broadcast in. Well, this switch would broadcast it to the other, which then broadcasts it back, which then broadcasts it back, which then broadcasts it back, which then broadcasts it back. It will keep doing this forever. It will not stop. There's no mechanism in layer 2 with these MAC addresses to notice that there is a loop. There's no mechanism to count, and after a certain number of times that it goes by, you drop it. There's nothing like that in layer 2. In layer 3, there is a capability in the IP part of the packet called time to live. And it's not talking about the time on a clock. It's not talking about seconds. It's referring to, at least in IPv4, it's referring to the number of times a device goes through a router. Every time a packet goes through a router, it decreases the time to live by 1. So if I send out a packet with a time to live of 4, as soon as it gets through the 4th router, the time to live gets to 0. The router says, wait a second, you've gone through 4 hops already. Your time to live has now been decreased every time. I'm now decreasing it to 0, and I'm dropping that on the floor. That way, if there was a loop between routers, and you see routing loops all the time when you're working with routers, it's a misconfiguration or something goes wrong with the way your your routing setup was working with your dynamic routing protocols, or maybe you statically configured it improperly where two routers suddenly talk to each other. Oh, to get to that subnet, we go to here. No, you go to here. No, you go to here. No, you go to here. And they bounce around until time to live gets to 0 and routers drop that. You don't have that mechanism at layer 2. The Ethernet network doesn't have a way to know that there's a loop. So you have to have some mechanism in place to be able to stop these things from happening, because you stick one packet on there and that broadcast goes around, you probably can tolerate that. Then you put 10, then you put 100, then you put 1,000. They're never going away. And you can very, very quickly bring down an entire network just by improperly connecting two devices together. Imagine you're in a data center and you accidentally connect two switches and then connect them again to each other, and you've brought down hundreds and hundreds of devices. This can be done quite easily. I can speak from watching people do this from experience. Me personally, I've seen this happen. You don't want that to happen on your switched network. So one of the ways you can prevent this is by using something called the spanning tree protocol. This is an IEEE standard, goes back to the 802.1d. You'll often hear it referred to that, although there are newer versions of spanning tree that are out there, or a rapid spanning tree protocol and some other proprietary methods as well. This methodology is one that's been around since 1990, since we've been doing bridging. Before switches, we were doing spanning tree protocol. And Radia Perlman created this technology, built this technology. She has a great book called Interconnections, Bridges and Routers that really goes into detail. It is a book used in colleges. It's a standard in our industry, a lot like Comer's IP books. It's a standard that should be on your bookshelf if you're doing hardcore switching, routing, bridging. It's a great place to have that information available and to be able to gather that. This is something that everyone is using to some degree, because once you start putting in multiple switches, you want to avoid ever creating a loop and bringing down the entire network. This is something that does come in handy when we're talking about spanning tree. You've got these bridges, these switches all in your environment, and the switches are just going to always talk to each other. They're always communicating back and forth. How you doing? I'm fine. How are you doing? I'm good. Hey, I'm over here, and here's my bridge number. And I'm going to send back and forth these information packets called BPDUs, these bridge protocol data units. These BPDUs are also going to inform other switches when a topology change occurs. Anytime there's any change, you lose a link, the link drops off of that switch is going to let everybody else know, I have no way to get to that subnet any longer. By default, this is what we want to have happen. We want all these switches talking to each other, being able to communicate and send that information back and forth. There is also a default interval where all the switches send hellos to each other every 2 seconds, which seems like a lot. That seems like it's doing it very quickly. Every 2 seconds, hi, I'm here. Hi, I'm here. 2 seconds goes by. Hi, I'm here. And constantly sending hellos to each other. But in reality, that's nothing. On a network, there were thousands and thousands of packets that went back and forth during that time frame, sometimes a larger number on the higher speed networks. So you've got this idea of hellos that are there. And the reason we do it with such short time frames is if we miss a hello from a device, hey, he hasn't talked to me in 2 seconds. Now it's been 4 seconds. Now it's been 6 seconds. If I miss 3 hellos by default, I say, oh, that device isn't there anymore. Hey, everybody, Fred's not on the network anymore. I don't know what happened to him, but we all need to talk to each other and come up with a new way to send traffic so that we don't create any loops. That is a process called convergence, and it's one that's very common to see on spanning tree networks. This spanning tree network, if you look at this picture, there's a lot going on here, but there are many different devices, these switches that you can see on the network. And this particular view, anything that is a root port, there's always a root bridge on the network, and it is elected. When everything is connected together, one device says, I am the root, and it's usually based on a root ID that is associated with it, so that he's sort of the command and control of everything. Everybody talks up to me, I'm the root. and everybody else is aware of where the root is. In fact, there's a port on every switch that is the root port that says, if I ever need to talk to the root, I go this way. That's the blue ports on here. The green ports are ports that are enabled on that switch, and anytime there could be a possible loop, the switches have already worked it out and blocked certain interfaces. Anything that's red is an interface on here that is a blocked port, which is great to be able to see this. And in chat room, people say, oh yeah, I've seen these BPDUs. You plug into a network, they are multicast. So you can plug in without anything extra. On your machine that's plugged into a normal switch port, you will see those BPDUs going back and forth. If you ever lose a connection, maybe a link goes down, maybe somebody cut the fiber between a building, maybe somebody unplugged something they weren't supposed to unplug, and those hellos stopped going back and forth, then everybody readjusts. And when that readjustment takes place, they now decide, I'm going to use a different communication to get around the network. And that convergence process occurs. Usually, in the case of the standard spanning tree, can sometimes take up to 30 seconds to be able to have that process occur, sometimes longer if your hellos are different. That's why we came up with the rapid spanning tree protocols. There's a faster set of spanning tree protocols that can react much faster and have these convergences occur and be finished in a matter of seconds, so that you're sending traffic, you don't even realize that the network reassigned how the traffic flows. It just happened behind the scenes, and seconds later, everything's continuing. It's like a hiccup. You didn't even realize it occurred. When you're looking at doing things like spanning tree, you're always planning this out. This isn't something you do on a whim. It's not something you turn on by mistake. You're really planning this out. You're building a chart, maybe like this, that shows where all of your switches are, how they are connected. In fact, you should be able to, when you start getting into networking, you should be able to go into these environments and really understand exactly how these devices are communicating to each other. You'll have this all laid out, and you should be able to estimate exactly how this will be configured and set up when it does its first convergence. Very useful to have that spanning tree. And as I mentioned, spanning tree, a layer 2 technology. Layer 3 has its own thing going on. Now, if you're back to the question that really came up earlier was, why am I not using multiple links and having load balancing to these other connections? There are a number of technologies out there that allow you to do these multiple connections to different locations using layer 2. And usually it's something like link aggregation, which is a little bit outside the scope of Network Plus, but that's a very common way for our organizations to set up multiple links to multiple switches. And if you lose one of them, the link continues to flow across the other one. So there are redundant functionalities in layer 2 that are a bit outside the scope. But when you're trying to prevent loops, it's layer 2, it's switching, and it is the spanning tree protocol. One of the questions that came in from Adam was talking about the GTS Learning Labs. I've talked about these on previous study groups and how they can be used for your Network Plus certification. Some of you may realize, of course, that the Network Plus certification not only asks you multiple choice questions, but they also expect you to be able to perform performance-based questions. These are questions that might ask you to match different things on the screen, or they may give you a command line and ask you to, in a simulator mode, perform a ping, perform a trace route, perform a netstat, and you have to be able to do that. If you'd like to do this in a lab that's already set up, you might want to use something from GTS Learning called Freestyle. These are the live labs, and you can find them at professormesser.com/netlabs. They are a complete virtual environment where Wireshark is set up, multiple devices, Active Directory servers, Linux devices, and it's got labs already for you to begin sending information between those devices, capturing the packets, and to begin understanding how that communication process occurred. You'll also, because these are virtual, they're not on your computer. You don't install any software on your computer. It's all done in a browser. On the latest browsers, it all works in HTML5. A lot of great functionality to be able to have all of those labs and everything available that you can simply connect to from a browser and be able to use and not have to install anything on your local device. You don't have to have any extra equipment in your in your home or in your office. It's all there. And I've got special pricing on this. If you go to professormesser.com/netlabs, I work with GTS Learning to get the price down to $99 for a year. There's also a free 1-hour sample. So if you wanted to try it yourself and see, is this right for me? You can go right out to that link at professormesser.com/netlabs and sign up for a 1-hour trial. And that's another thing that you can do to see if it works for you, something you might want to try. A lot of people have given me some great feedback about how they were able to step through a common scenario in networking and be able to have the packets, be able to work with the router, be able to see the switching. It's all in the NetLabs. You can find those professormesser.com/netlabs. Well, I know we're coming up on the top of the hour. There's a lot going on here. And so I've got more questions for you. So we're going to go a little bit long, I think, in this one. Before we go to the questions about the questions, I'm going to go back to that 111 area code. Are you there, caller?
Hello?
Hello. How are you? What's your name?
Hi, it's M.A. Graham again.
Hello. Thanks for calling.
I'm on your network chat, and I've called before.
Yep, I see you there. Thanks for calling.
I have my Network Plus exam tomorrow. So that'll be seconds. I already passed A+ in October.
So you're doing this by tomorrow for you. Is that Sunday you're taking the exam?
Yes, Sunday.
So you've got an exam center that's open on Sunday. That's nice to have, actually.
Yes, it is. And although it'll be interesting because it's snowing where I am up here now, we'll see if it stays open. Anyway, my question is about wireless routers. I came up on a different standard that I had not seen before in my studies. Obviously, 802.11n is the current router, highest router in the Network Plus program.
It is.
But I have also seen 802.11.AC router.
Oh,
now,
yes.
Which I assume will be handled in the next version of the software. Do you consider those to be ODFM type routers, orthogonal frequency division multiplexer?
The 802.11 AC, and you're right, it's not on the Network Plus certification. It's not part of the Network Plus certification. And what it does, it is, and because it's a new technology, and this is one of the challenges with networking, is that we're getting constant newer versions of these technologies out. The 802.11 standard is one that was finally approved recently. It's not one, it's been in development. And this is one of the challenges with networking. Everybody wants their wireless network to go as fast as possible. And
I believe it was just approved this month.
Yep, in January. You're correct. And except you were able to buy an 802.11 AC wireless device months ago. You were able to go to the big box store and purchase one. I have one that is an AC device. And because what they'll do, the manufacturers have the latest draft of the AC standard. And what they'll do is they'll build their technology to work with that standard. And even if it changes a bit when it's finally ratified, they have firmware available that they can provide to you that you can apply to your device so that you're up to the latest standard. But they try to jump the gun as fast as possible because it's such a fast capability. It's using a different modulation than the other technologies. You have to be able to get the speeds out of this. We're talking about a gigabit per second to be able to go through these wireless connections using a QAM, 256 QAM to be able to, it's QAM to be able to do this. But in the industry, we call it QAM. If you've been working at all with cable modem technologies, they use a similar type of modulation to be able to do this.
Yeah.
So it is backwards compatible with your N and with your G and I guess B as well. But it is really designed as a completely new standard. It's another one of those scenarios where the only way you're going to be able to get the highest throughput is if you have everything on your network running at 802.11 AC. But you're right, it's not part of the Network Plus certification. You don't have to know anything about what we just talked about when you walk into your exam tomorrow. But it's an exciting technology. I'm looking forward to using it. It'll be interesting to see what type of throughputs we can really get from it.
Yeah, I'm seeing such things as 1.3, gigabits per second, but that's, I think, the hypothetical, like 600 is hypothetical for N.
Yeah, and you're seeing multiple streams, and because it has different frequencies, we're now having more of a full duplex communication. Because one of the challenges we have with older wireless is that they used a single frequency, which meant when they were transmitting, they couldn't hear anything. It would effectively overload their local receiver. So they had to transmit and then listen to see if anything else was going on. So it was more of a single connection, a simplex communication. Well, now we can do full duplex communication on these. So you can get really, really high speeds out of these wireless networks because we can send and receive both at the same time. It's what we've needed for a very, very long time. Hopefully I can get better distances from the AC than what I'm getting on my N right now. I'm looking forward to trying some different antennas with it as well.
Well, I appreciate that. I look forward to taking the exam tomorrow and to take Security Plus in another couple of months. Hopefully I'll get 301 in before they change to 401. So
I think you will.
We'll
and
see what happens with that.
Best of luck with the Network Plus certification tomorrow. Let us know how it goes.
Thank you very much.
And thanks for calling. I think there's one of the challenges with networking is that it's constantly changing. There's constant updates. There's constant. One thing I found, though, is that some of these are kind of slowing down a little bit more. When you look at the differences between the 004 and the 005 with Network Plus, I saw a lot of things that were the same, and then they added on some extras, like added on a little more security, added on virtualization technologies, things that were newer. I'm looking over the Security Plus certification, and there's very little that's changed between the 301 and the 401. I'll be able to use practically the same videos for the 401 as I have for the 301 with some minor additions, very minor additions. So we wish you best of luck on your exam tomorrow. It sounds like you're going to do fine. You've got the right idea. You're already looking at 802.11ac and how the wireless works and the modulations. I think you've got the right idea with getting those things done. Let's have a look at some of the questions you folks sent in to me about the exam itself. So we go back to our questions. One came from Lionel that said, do you think it's important to take the A+ before the Network Plus? What is really the difference here? And this is a common question that we do get when we start looking at these exams. If you look at what CompTIA says, CompTIA would like you to first take A+, then they say you should take Network Plus, then they say you should take Security Plus. Now, the reality is if you grab the exam objectives for all of these exams, you'll notice that the A+ and the Network Plus don't have a lot of overlap. There is a networking section on the A+, and it's relatively small compared to both of those A+ exams you would take. You have a lot more networking on the network. And I think if you don't need the A+, but you do need the Network Plus, you can jump right into the Network Plus. You don't need to necessarily take the A+. The Network Plus will bring you up to speed on what was covered on the A+ exam. It's all in there, so you'll be fine. When you go from Network Plus to Security Plus, however, a lot of the security concepts, many of them have nothing to do with networking. So part of me says, yes, you could jump right into Security Plus without going the Network Plus route, but there's so much of security that has a networking foundation that it would really help you if you had a network certification or at least some network knowledge before jumping into the Security Plus. But even that one, you could almost get away with jumping right to security. I'm a bad person to ask because the first one I got was the Security Plus. Then I did the Network Plus. Then I did A+. So I did it in exactly the wrong way, according to CompTIA. I did it exactly backwards, according to what they would recommend that people do. If you go out to the CompTIA website and you have a look at that, let me pull up the website view and we can look at those pieces. And I go to the certification tab right here at the top that you can't see very well. And you look at things like, that's Server Plus, Security Plus. We go to the Security Plus page. Security Plus, they say if you scroll down a bit, 100 questions, multiple choice, it says that the recommended experience is the Network Plus certification and 2 years of technical networking experience with an emphasis on security. I think that's a very conservative piece, but it kind of fits what I just said, is that some networking foundation is really, really going to help you when you get to Security Plus. Now, if you look at Network Plus, which is really the question that Lionel asked, and we look at the same information on here, they say we recommend that you have an A+ certification and 9 months networking experience. I'll go with the 9 months networking. I don't necessarily agree that you have to have an A+ before you jump in. The best way to tell would be to download the exam objectives, which are right here at the top of every single exam breakdown, and see for yourself how much you understand of those. And then look at the A+ and see if that makes sense as well. I think there's some great options available that you'll be able to work with. I think the idea is that it's different for everyone. Look at the exam objectives. You'll be able to tell yourself. And I think exam objectives is a great place to go. The question that came in from Bradley was, I'm taking my Network Plus exam next week. What's the best way to make sure I'm ready? And I like the idea of grabbing the exam objectives. The exam objectives have everything you need to know for the certification. In fact, if we go back to the Network Plus page and have a look, there's a big, right at the top of this page, I'm on the CompTIA website at CompTIA.org. I clicked certifications, I clicked the Network Plus, and I went to the Network Plus page right at the top, view exam objectives, view sample questions, which I think are the two most popular questions I get. So that's pretty important. Let's view exam objectives. It's going to ask you for some information from you. Let's type this in. Everyone can send me an email at james@professormesser.com. It's one of those things where my email, just send me the email. Everybody has my email. Get the exam objectives. It even has the older objectives out there. We obviously are studying for the N10005. It's odd that they have the old ones. I don't think they're really testing on the old ones anymore. That may just be there a long time. So if we have the exam objectives and pull them up, I'm in Chrome, so it just brings it right up without a PDF reader. You can see everything you need to know on the exam. So this is your checklist. Before you walk in, go to section 1, networking concepts, 1.1, compare the layers of the OSI and the TCP/IP models. Here's my OSI model, layer 1 through 7. Now, do I know that? Do I not know that? I can put a check mark. Yep, I know the OSI model. Let's see. Do I know the TCP/IP model, which is network, internet, transport, and application? Okay, yes, I know that. We can go to the next one. So you can go through this just as a big checklist. And if you're in a PDF reader that's not in your browser, my PDF reader that's external to this even allows me to make annotations on the page. I can highlight different pieces. I can make them green. I can make them red. So I can see visually where I need to go back. You may not even have to print this out. You can go right here down the screen and figure it out. And if you get to the part where I didn't even know that was on the exam, I need to go read about it, there's your chance to go to Wikipedia. There's your chance to pull out your book. There's your chance to look at your study notes. You can look at all of those pieces to understand more about exactly what they're asking about so that you can really see what's going on. There's a lot in the guides. And whether you're taking your A+, your Network Plus, your Security Plus, any CompTIA exam, download these exam objectives. Not every manufacturer, not every certification exam, very few certifications exams go anywhere close to this level of detail. Microsoft doesn't give you this. Cisco doesn't give you this. These other certifications you'll find, VMware doesn't give you this. CompTIA is very unique at really giving you a detailed breakdown of what you need to know. Make sure you understand that. It's heart-wrenching to have someone come into the chat room and say, I didn't pass my exam. And we ask, well, what part of the exam objectives did you find was an issue? Or they say, they asked me questions I had no idea would be on the exam. And we say, did you download those? They had no idea these even existed. They're very, very valuable. Most of your books will also have the exam objectives in there. So take advantage of the book you're reading. It will probably have an appendix with this exam objective. You may want to make sure that the exam objective that you have is one that is also the latest version, because they sometimes will update them as they go. Let's look at a question that came in last month that I think I kind of answered, but I found out more information in the meantime. It deals specifically with renewing. There is a CompTIA, when you get your exam, let's say you pass your Network Plus certification exam, it's good for 3 years. And at the end of 3 years, it expires. So it's only good for a certain amount of time. Now, what CompTIA allows you to do is to renew that certification so that you don't have to take the exam all over again. Nobody wants their exam to expire and then they have to take it again. It would be great if we could just renew it. And one of the things you can do is to renew it by performing continuing education credits. You get these CEUs, continuing education units. By watching this 1 hour, now over 1 hour web event, you can also get credits for this if you send me an email that has a list of all of the questions that were asked during this event. And I've got all those questions you saw pop up on the screen. If you send me a list of those questions, I'll send you back a notice that says, yes, you watched this whole thing. You get a certain number of units updated, and you can collect these units. And when you have a certain amount, you can renew your certification. Now, when you do that, when you collect these CEUs, you have to also pay CompTIA to maintain that database for you. But there is a way to renew your certification without having to pay CompTIA. And the way that you do that is by taking a CompTIA exam. If you can take a higher level CompTIA exam, it will automatically renew your lower level CompTIA certifications, and you don't have to pay them any money. But that's only if you take a CompTIA exam. You may realize also you can take exams from other third parties. You could take a Cisco exam, a Checkpoint exam, a VMware exam, an Oracle exam. There's a lot of exams out there that you can take. And those exams will also renew your CompTIA exams, but you have to then give CompTIA money to maintain that list. The way I found this, I called some folks, but the way I found it, it wasn't easy. If you look at the CompTIA website, and let's do exactly that. The CompTIA website has on it a continuing education link, and it tells you all about what you need to know to participate in the continuing education program. And it says you achieve a higher level cert, you complete activities, you take a new version, and they talk about the things you have to do. You have to sign the continuing education code of ethics policy, you have to pay the 3-year maintenance fees, and you have to upload your requirements. So it sounds like there, you got to pay. You don't have a choice. But actually, if you go up to the help section at the top of the page, which of course isn't in the continuing education section, it's just a link that says help. And in that help section will be a list of things, and we want to choose the one that says continuing education. I'm just going to click the big icon that says continuing education. There's a link in here that says pay and track CE fees, and it says to pay your continuing education fees, go here. But it also says if you scroll down, higher level CompTIA certifications automatically renew lower level certifications, and no CE fee is required. Refer to this for the list of CompTIA certifications that are applicable, and they give you a list of these. It is the A+ at the bottom, Network Plus, Mobility Plus, Security Plus, Storage Plus, Cloud Plus, and the CASP, which is the higher level security practitioner exam. So if you have the Network Plus, you can renew it by taking any of these higher level, Mobility, Security, Storage, Cloud, and CASP. And you don't have to pay any money. So there's my tip for you this month that might help you pass the exam without having to give anybody any money, renew that exam without giving anybody any money. That can help as well. So there is also a lot you can do during that time frame. Maybe you do want to pay the money and do this through the CEUs, but at least it's good to have that option. Now, before we close out the study group, I have a question for you because I like to know what you want to get on your Network Plus study group for next time. So I have a vote that you can do, and this is not a multiple choice question. This is one where you can type in the information that you would like to have in that list. You can go to vot.rs number 826815 or click that QR code reader, and it will show me the list of things that you would like to cover next time. And I'll have not only, I'm going to show you a word cloud, but I have access to the entire list of things that you're typing in. So if you have a very specific request, you can absolutely type it in right there. So it's very useful to have that capability. So I can see whenever I put this together, I went to that list from last month, got everything that was there, and I applied it back to some of the things that we went through in this one. So if you go to vot.rs number 826815 to be able to vote on those. We've got a couple of calls holding. So before we close things out, I'm going to take a couple of calls. We've got the 661 area code. Are you there, caller?
Yes. How you doing this morning?
Hello.
Who's Anthony Canty?
Hey, Anthony. How are you?
I'm fine, thank you. How's everything going your way?
So far, so good. Thank you.
Good, good. Yeah, that study, what do you call it, for CompTIA. It really helps because I started using it, and it walks you through everything. And since I've been going on your site and going through the process from the beginning to the end on the first part of the 801, a lot of things I can check off because I've been doing it for quite a while. But yes, it really does help you.
I think the objectives are this little diamond that if you know it's there, it can really, really help you. And I just try to get the word out. And I say this every time we do a study group. And I think those of you that have watched the study group over and over are tired of me saying it. But unfortunately, I still get people every month that had no idea it was there. And they're either just about to take the exam or they took their exam and they were surprised. And I'd like to avoid that if at all possible.
Yeah, everything that you need to know is right there. I mean, they take you through everything. There's nothing that's missing, and you don't have to do any extra studying for things you might not need because right there it has everything you need for the exam.
This is one of the things, because I take a lot of certification exams from other places that, you know, a lot of things are going on in the other part of my world that don't ever show up on the Professor Messer website. And so I'm taking other manufacturer certifications all the time. And sometimes I get frustrated because they don't give you a lot of detail, and I'm spoiled. I'm so used to seeing the Network Plus exam objectives or the Security Plus or just having everything there and using it as a checklist. So I think that's a great comment and a great recommendation to everybody listening. Go get those. And here Anthony's telling you as well.
Yeah, we used those, and I didn't realize that when I was in the ROC class for the adult school here, and the teacher did use those objectives. And I was sitting down in the room the other day, and I said, wait a minute, these are the same objectives that we did for the Strata. So if I just follow the same guideline, I'll be fine.
See, that's a smart teacher. You go right to where the information's listed, and when you're ready to sit down for the exam, you've gone through exactly what you needed to know.
Exactly. Now, I have a question this morning.
Sure.
I was working on a computer, and I couldn't get it to boot into the operating system. I would put it in safe mode. It would go in safe mode. Once I clicked on safe mode to get it to boot up where I was, in safe mode, it wouldn't go back to safe mode. It would go back to booting all over again the computer.
Yep.
It didn't give me a blue screen, but everything I tried to do, nothing would work. It would always act like it was going to boot up, but it would boot right back to the beginning of the operating and then start all over again.
Sure. Yep. And whenever one of the things for those of you that haven't worked a lot with safe mode in Windows, one of the nice things about safe mode, it starts up Windows, but kind of a crippled version of Windows where it doesn't load every possible thing associated with the operating system. It loads just the bare minimums. And you can even tell it, load it without networking, load it with networking. But the problem you have, of course, is what if one of those core pieces of the operating system is the thing that loads even in safe mode? And if that's corrupted or damaged, it could very possibly cause the system to restart in safe mode. It's not even going to work for you. And in those scenarios, you may not have a choice. You may have to do a repair installation where you're effectively installing Windows all over again. So you obviously have to have the installation media to be able to do this. Ideally, the same installation media that's currently installed with the same service packs and everything. It doesn't have to be, but ideally that's what it would be. And you would just...
when I put excuse me for
sure, no, go ahead.
I put the installation disk in there, and I tried to get to the console to... go to the command prompt to check to maybe rebuild the MBR.
Right.
It would boot back to the same thing.
Yeah, I have a sneaking suspicion that the problem is either a core piece of the Windows operating system, the kernel, one of the drivers that starts up very early with the hardware abstraction layer, something in the very beginnings of the core of the operating system that's the problem. So it's not even going to get you to a command prompt, or there may be something wrong with the storage media itself, with the hard drive or the SSD or whatever is running inside of that device. In those cases, the only thing you could even try is to boot with the original media and perform an installation into the same directory. And we call that a recovery or the installation over an existing installation to try to get things are sort of rewritten in Windows. It's not going to overwrite your data. It's not going to overwrite your applications. It will overwrite the base of Windows, but it leaves everything in place. This recovery method effectively reinstalls the core operating system of Windows and leaves everything else there. it's not guaranteed to work, but at least it gives you a fresh Windows to work with so that you can at least tell, is my problem with the operating system or is my problem something with the hardware?
What I had to finally do was take the hard drive out. I put another hard drive in that I know that
Yep.
was IDE.
That'll do it.
And it booted up fine.
Mm-hmm.
So I put the other ID into my dock and just took out the information that the guy needed and just reinstalled the operating system on that same hard drive.
It would be
No,
interesting.
not on that hard drive, on another hard drive
Right.
that I put in.
It would be interesting to see if you had the time to do a hard drive diagnostic on that. Is it really the hard drive, or was it the operating system, or you got the problem fixed? So that may just be a waste of time. It'd be more of something just to step through to see how it's
A little
working.
extra study.
Yeah, why not? But and a lot of people in the chat room are going, "Gosh, that sounds like a virus. Sounds like malware." It certainly could be. Although malware these days like to keep your system running so they can use it for other things. It's hard to find one that just cripples your machine unless it's one of the cyber lockers these days that are trying to lock you out of your system. They don't want your system to reboot either. But I think
it seems like this gentleman was running it without an antivirus, and he does taxes and real estate. And I asked him, "How are you running a computer without antivirus?"
not well is the answer. Apparently. That's a challenge for anyone who's trying to and it's also extremely unusual that somebody they know taxes, they know how to do that piece of it. They just don't have anybody to rely on to tell them you really should have put antivirus on this system. Hopefully you did that before giving it back.
Yes, I did.
Oh, good.
Yes, I did. I put a VAST on there and
Good.
he downloaded his information into the hard drive, and he's good to go.
Anything is better than nothing on those systems. So that's
Exactly.
a good story and a common occurrence, unfortunately. Well, thanks for calling, Anthony, and thanks for being in the chat room.
Thank you. You have a good day.
Thanks, you too. I've got another call in. This also 661. I don't know if that's really the same one or not. Are you there, caller? It's very quiet. Let's see if the caller's there. I don't think so. Boy, that was the quietest caller there is on that one. I know in the chat room we're talking about crypto locker, the cyber locker that encrypts all of your data and holds you hostage. Not a fun place to be with that one. Well, we've spent well over an hour to go through these pieces. I will remind you again, we have that. If you've finished going through all the videos, you've read your book, you need those extra notes, I have those study guides available for you. For $10, you can find them at professormesser.com/netsg. And of course, you can find this video replay will be on YouTube. You can, of course, subscribe to my YouTube channel at professormesser.com/YouTube. Of course, you can find me on Twitter where we have our daily A+ pop quiz. Some of you have been prodding me to do a Network Plus pop quiz. We'll have to see if I can make that happen. It's a big mystery. Is it going to happen or not? I do put things on Google Plus as well. And of course on Facebook. Facebook, a little bit more of a challenge because it doesn't blast it out to everybody. Twitter is a much better way to do that. And Google Plus is a much better way to do that, unfortunately. But some of you probably follow that on Facebook as well. So if you have an account there, you can, of course, follow me there. GTS Learning, we want to thank them for sponsoring what we do, giving us a great price on the labs. You can find that at professormesser.com/netlabs. And, of course, thanks for everybody who joined us. We wouldn't be able to do these study groups if we didn't have you here helping us all the way through. This is one of the things that I run into when I'm working with all of these pieces is I have to come up with questions for the study group, and this is where I go to you. And you, every single time, you've been able to give me information and get us through, in this case, well over an hour's worth of content. So thanks again for everything. Thanks for your support of the website. We're going to see you next month on the Professor Messer Network Plus Study Group.